Today, everybody, we're looking for a positive integer n such that this exponential expression is a square integer, and by that I just mean it's equal to k squared for some k in integer. All right. Now it turns out to be fairly routine. Really, the main idea here is just to go ahead and make the assumption, which is not it's a very valid assumption, that n is greater than or equal to 8. Notice that if n were less than 8, you would get a negative exponent here, which wouldn't make any sense in this context since we're looking for a square integer. Okay, so we're assuming that n is greater than or equal to 8, and we go ahead and factor the 3 to the 8th out. So we have this factored expression, and notice that 3 to the 8th is already a perfect square all by itself. In other words, 3 to the 8th is the same as 3 to the 4th squared, right? So that part we don't have anything to worry about. We just need to force the parenthetical piece to be a perfect square. We want this guy here to be perfect square. So there's nothing too imaginative going on now. We're just going to look for, we're going to go case by case by case. And notice that we get the job done when we get to n equals 10. Okay, n equals 10 gives us 10 squared. So the product of squares is also a square, right? So we have that going on right now for the case n equals 10. You can see we already know the answer. This would be 3 to the 8th times 10 squared. So we can go ahead and finish it off by just saying that this is equal to 3 to the 8th. And this would be for n equals 10, of course, which is our answer. I don't know if there's any others, really. There's bound to be some more perfect squares in this list. I'm not sure how to determine that, though. But this would be 3 to the 8th. We've already seen that this part right here is times 10 squared, right? And so this is equal to 3 to the 4th times 10. Okay. 3 to the 4th times 10, quantity squared. All right, so it is a perfect square because it's equal to this thing squared. I'm not even going to, that's 8100, I guess, or 810. Yeah, we can do that. That's not too hard to do, is it? So this is equal to 810 squared. So that's kind of nice. That's 3 to the 4th, right? That part of it at least. So maybe there's something going on with that. But in any event, we've found the n equals 10 does it. And again, there may be some larger ones. There's certainly not any smaller ones, I don't think. But we got n equals 10 leads to this. Okay, so let me come up here. So this would be equal to 810 quantity squared. For n equals 10. And maybe if you could have guessed 10 at the beginning and worked from here, maybe it would work out nicely too, but you'd have to guess it, I guess. Anyway, it's interesting that one of the powers that's already present is the one that's, maybe there's something going on there. But in any event, this is a way to just kind of forcefully do it by using factoring techniques. Okay.